welcome back to another session of construction planning. Students, in the construction planning, we are discussing network methods, and in the network methods, we are discussing PERT method. So in the previous session, we have seen the technical fundamental of the PERT method, and then we have started a numerical of PERT method. So in the technical fundamental of PERT method, we have learned that PERT is an event oriented method. Full form of PERT is program evaluation review technique. Then in PERT method, it follows 3 time estimate such as optimistic time, most likely time, and pessimistic time. On the basis of that 3 estimate, we need to convert it into single estimate, and for that there is a formula, expected time TE. So TE equals to TO for TM plus TP divided by 6. Now after that, in PERT method, to find the critical path, we have understood the concept of slack. So what is slack? Slack is the difference between event timings, latest event time minus earliest event time, that is our slack. And then we have done the first numerical based on PERT method, in which we have understood the concept of probability. So when there is the concept of probabilities involved, there is a formula Z equals to TS minus TE upon under root sigma square. So TS, schedule time, minus TE, total expected time, under root sigma square, that is square root of sum of variances of critical activities. Alright, so that was the overall concept of PERT method. Today in this session, we are going to look at another numericals based on PERT method. So let us start with our question number 2 of PERT method. So the question says that a network is shown in figure. Determine the total expected time for each path and determine critical path. We have a network given in question, and in that question we have been asked that find the total expected time for each path. Second, determine critical path. Now let us see the network first. So as you can see over here, students, the network is given to us consisting of event number 1 to 7, and the connections are directly given. Also, as you can see in the figure, activity timings are directly represented on arrow of the activity. Now we have understood this concept last time, that if there is no information given about who is TO, TM, TP, so in the representation of that timings on the arrow, first is TO, center TM, and last is TP. That is the basic rule or basic concept. So now let us focus on our first question. Determine the total expected path for each project. So here, what do you mean by path? Students, path, that means connection from event number 1 to 7. So now let us look at the network closely and see how many ways we can reach from event number 1 to 7. So the first path which we can see in the network is the upper path 1 to 4, 4 to 5, and 5 to 7. 1 to 2, 2 to 4, 4 to 5, 5 to 7. Second path is 1 to 2, 2 to 3, 3 to 5, 5 to 7. Third path is 1 to 3, 3 to 5, 5 to 7. Fourth path is 1 to 3, 3 to 6, 6 to 7. And the last path is 1 to 2, 2 to 3, 3 to 6, 6 to 7. So there are 5 possible paths to reach event number 1 to 7. I have just tell you the 5 paths. So let me highlight all the paths one by one. Alright, so that is my path number 1. That is my path number 1. 1 to 2, 2 to 4, 4 to 5, 5 to 7. Let us see the second path. So the second path is 1 to 2, 2 to 3, 3 to 5, 5 to 7. Third one. So the third path is 1 to 3, 3 to 5, 5 to 7. Fourth path. 1 to 3, 3 to 6, 6 to 7. And the last path, that is 1 to 2, 2 to 3, 3 to 6, 6 to 7. So let us list all the paths. So here is the list of all the available paths. I have named them A, B, C, D, E. So these are all the available paths from reaching point number 1, event number 1 to event number 7. Students, that is half of our first question. Our first question was find the total expected time for each path. So first we have derived how many paths are there. Now the remaining part of the question, that is total expected time for each path. So to find the total expected path, we know that we need to calculate TE, individual expected time for each activity of each path. So let us begin with path A. And to find the TE, we have the formula that TE equals to TO plus 4TM plus TP divided by 6. So now let us start with path number A. Alright, so here is the table containing the column path, activity, TO, TM, TP, TE and sigma TE, that is total expected time for individual path. So we are talking about path number A. Now path number A is consisting of activities 1, 2, 2, 4, 4, 5, 5, 7. Now let us see the TO, TM, TP data for these 4 activities. So here are the TO, TM, TP data for those 4 activities. So from the formula we can calculate the expected time for each individual activity. So here for activity 1, 2, TO is 6, TM is 10, TP is 14. So TE will be 10. Similarly for activity 2-4. So TO, TM, TP is 4, 7, 16. So TE will be 8. So that is how we need to calculate TE for all the activities of path A. Let us see that. So here is the individual TE for all the activities of the path A. 10, 8, 0, 9. 10, 8, 0, 9. So sigma TE will be 27. Sigma TE will be 27. So that is for path A. Now let us look at for path B. So path B is consisting of again 4 activities 1 to 2, 2 to 3, 3 to 5, 5 to 7. Alright. Now let us look at the TO, TM, TP data of all the activities of path B. So here is the TOTM TP data 3-time estimate for path B. Now using formula, let us calculate the expected time for each activity of path B. So here is the total expected time 10, 5, 2, 9. 10, 5, 2, 9. So the total expected time will be 26. Total expected time will be 26. Now let us see for path C. Path C is consisting of 3 activities 1, 3, 3, 5, 5, 7. So looking at the TOTM TP data of them, the total expected time for path C will be 19. Similarly, we can perform for path D. So the total expected time for path D will be 20. And now that is the last path consisting of 4 activities 1, 2, 2, 3, 3, 6, 6, 7. So when we calculate for path E, the total expected time will be 27. Alright, I hope we are clear up to this point. So we have answered, we have found the answer of question first, that calculate the total expected time for each available path. Now the second question is determine the critical path. So we know that to find the critical path in any network, whether it is CPM method or PERT method, we need to conduct forward and backward analysis. Now from this ABCDE path, we know the individual timing of the activity. So let us represent that individual timings in the network. Alright, so here is the network with the individual timings. Here is the network with the individual timings. Now we need to perform forward and backward analysis. So starting with point 0. So 1 to 2. So the duration for 1 to 2 is 10. So 0 plus 10, 10. Now for 3, there are 2 paths. 1, 2, 3, 2, 2, 3. For 1, 2, 3, 0 plus 8, 8. But from 2 to 3, 10 plus 5, 15. So we'll consider 15. Now for event number 4, there is only one path, 2 to 4. So 10 plus 8, 18. Now for event number 5, there are 2 ways, 4 to 5 dummy and 3 to 5. So 4 to 5 dummy is 18 plus 0, 18. And 3 to 5, 15 plus 2, 17. So maximum is 18. Now event number 6, there is only one path, 3 to 6. So 15 plus 7, 22. And the last event is event number 7. So event number 7, that is 15, 6 to 7, 5 to 7. 18 plus 9, 27. 15 and 22 plus 5, 27. So both are the same, so 27. And hence now let us do the backward calculation. So again we'll be starting from 27 above, so 27 below, then 7 to 6. So 27 minus 7 to 6, so 27 minus 5, so 22. Now for 5, so 7 to 5. So 27 minus 9, 18. Now for event number 4, so 18 minus 0, 18. For event number 3, there are 2 options, 5 to 3, 6 to 3. So 18 minus 2, 16, 22 minus 7, 15. So minimum is 15. So event number 3 we are clear. Now for event number 2, again there are 2 options, 3 to 2, 4 to 2. So if I go from 4 to 2, 18 minus 8, 10. If I go from 3 to 2, 15 minus 5, 10. So both are same, we can get any one. And for event number 1, as you know, 10 minus 10, 0. And the other option is 15 minus 8, that is 7. So 0, 0 and 7, minimum is 0. So that is how we have conducted our forward and backward analysis. Look at the network again. Students, all the head event and tail event is the same. So the entire network is critical. So all the path can be critical. But now critical can be only one. So how to select the only one path? So students, when there is a scenario that more than one path is critical, check who gives the maximum answer. So there are two paths, path A and E having 27, as we have seen in the earlier. Path A and E is having total time 27. So there is a tie between the total based on total duration. Now when there is a tie based on total duration, check which path covers the maximum number of activities. Which path covers maximum number of activities? Both paths covers 4 activities. So we can represent the critical path as any of the path A or path E. Path A was 1, 2, 2, 4, 4, 5, 5, 7, while path E was 1, 2, 2, 3, 3, 6, 6, 7. So let us highlight one by one. So that is our path A, and now let us show the path E. So that is path E. So that is our completion of second numerical of PERT method. Now let us see another question. So the question says that a network given in figure is representing a construction project network having 3 time estimate marked on the each activity. Now find the following. First, total duration of the project and critical path, probability of the project for completing in the scheduled time of 40 days, and what will be the time of the project if the probability of the completion is 95%. Also, the corresponding value of Z had to be taken from the table. So here, as you can see, Z and probability table is given for 1.5, 1.6, 1.7 and 1.8. So here, students, for a network which we are going to see just now, we need to find 3 things: total duration and critical path. Second, probability of completing the project in 40 days, and time of the project if probability is 95%. So let us begin with the network. Alright, so as you can see in the figure, the network is given to you. Event number 1 to 8, 1, 2, 2, 3, 3, 4, 2, 2, 3, 2, 4, 2, 5, 3, 4, 3, 7 and so on. So that is how a network is given. On that, in this network, time estimates are represented TO-TM-TP. So we need to find the total duration and critical path. So we know that we need to find the total expected time by the formula TO plus 4TM plus TP divided by 6. So let us prepare the table. So here is the table for activity TO, TM, TP and TE. So now let us look at the TO, TM, TP data for each activity. So here is the 3 time estimate for each activity. Now using formula, let us calculate for each activity. So by using formula, for activity 1 it will be 5, for activity 2 it will be 8, for activity 3 pardon me, when I talk about activity 3, that is 1, 2, 2, 3, 2, 4. So for activity 2, 4, that will be 8, so pardon me, 12. For 2, 3, it will be 12, 2, 4, it is 8, 3, 4, that is dummy, so 0. So this is how we need to complete the entire table. Let us see the entire table. So here is the entire table of TE. Now this values of TE, now we need to put back in the network and do forward backward analysis. So let us put this all the values of TE back into the network. So here is, I have drawn the network again with the TE timings below the arrow. TE timings below the arrow. So now we can do the forward and backward path analysis. So as you know, to perform forward and backward path, we need to start from point 0. So 1 to 2, 1 to 2, 0 plus 5, 5. Now 2 to 3, there is only one way, 2 to 3. So 5 plus 12, that is 17. Now 2 to 4, 2 to 4. So there are two ways, 2 to 4 and 3 to 4. So 17 plus 0, 17, and 5 plus 8, 13. So maximum is 17. Now 2 to 5. So 5 plus 10, 15. Let us see for event number 6. So for event number 6, there is only one path, 4 to 6, 17 plus 10, 27. Now for event number 7, there are two ways, 3 to 7, 6 to 7. So if I go from 3 to 7, 17 plus 6, 23, and if I go from 6 to 7, that is 27 plus 4, 31. So maximum is 31. And the last activity is 7 to 8, 31 plus 4, 35. So that is our forward path calculation. Now for reverse path. So to start with reverse path, last point was 35. So I'll be starting again from 35. So 35 minus 4, 31. That is 8 to 7. Now coming to the 6. So 7 to 6. 31 minus again 4, 27. Now coming to the event number 5. 27 minus 8, 19. Now coming to the event number 4. 6 to 4. 27 minus 10, 17. Now coming to the event number 3, there are two options, 4 to 3, 7 to 3. So if I go from 7 to 3, 31 minus 6, 25, 17 minus 0, 17. Now for event number 2, there are two ways, there are three ways, 3 to 2, 4 to 2, 5 to 2. So the minimum will be 5. And now the last 5 minus 5, 0. So we came back to 0. So we got our first answer, total duration of the project, that is 35 days. Total duration of the project, that is 35 days. Now talking about the critical path. So critical path, TL minus TE should be 0. So the critical path will be 1, 2, 2, 3, 3, 4, 4, 6, 6, 7, 7, 8. 1, 2, 2, 3, 3, 4, 4, 6, 6, 7, 7, 8. So that is our first answer, total duration and critical path. Now let us talk about the second question, that is, what is the probability if I want to complete the project in 40 days? Now when we are involving the probability, concept of probability, we need to find the Z. So let us see the formula. So the formula for Z is Z equals to TS minus TE upon under root sigma square. So TS, that is schedule time, which is given in question. Here in our case, that is 40 days, minus TE, that is expected time, which we have just calculated, 35, divided by under root sigma square, that is square root of sum of variances of critical activities. So first we need to find the variances. So that in that table, that 3 estimate table, TO, TM, TP, we have calculated TE. Now let us prepare another column of variances. So the formula for variances is TP minus TO divided by 6 the whole square. Let us do that. So using that formula, we have calculated the variances of each activity, but in the formula of Z, all I need is the variances of sum of variances of square root of critical activities. So 1, 2, 2, 3, 3, 4, 4, 6, 6, 7, 7, 8. So I'll add up all the variances of that and I'll get the square root. Let us do that. So here is the calculation of under root sigma square, that is 2.87. Put this value in the Z. So Z is 40 minus 35 divided by 2.87. So we will get Z equals to 1.74. Now let us recall the table of Z. So here is the table of Z. So by interpolation we can get the value for probability. So we'll get the probability as 95.54%. So that is our second answer, that if we want to complete the project in 40 days, probability will be 95.54%. Now let us discuss about the third question. So students, third question is, what will be the time if probability is 95%? In general scenario, all we calculated is we have given a time, we have already a time, and we find the probability. But here in this case, we have got the probability and we need to find the TS. So let us discuss this case. So in generally, we use the formula Z equals to TS minus TE upon under root sigma square. But here TS is unknown. So Z into under root sigma square equals to TS minus TE. Now making the subject TS. So TS equals to Z into under root sigma square plus TE. That is our formula. Now 95% is the probability. We need to find Z. So recalling that table, by doing interpolation, we'll get the value of Z as 1.64. If you do the interpolation, we'll get the value of Z 1.65 or 1.64. So put that value. We got under root sigma square, we got TE. So we'll get the value of TE as 39.74 days. 39.74 days. We can round it off by 40 days. So students, that is our answer of question number 3. So that is our end of numerical number 3. I hope we are clear about it. We have seen all the types of numerical. What if there are multiple critical paths? What if there is timing given and probability asked? What if there is probability given and time is asked? Also, we regularly can find total duration and critical path of the network. So this is it. That was all about in today's session. In case of any query or doubt, you can always contact me on my mail or my number. Thank you.